This video is over lesson 73, multiplying and dividing positive and negative numbers, and it is for my 7th grade math class. So addition and subtraction are the weakest operations. Thus, when we add positive and negative numbers, we can visualize this on a number line using arrows to represent the number and just laying them next to each other. And if you think about your order of operations, this is why addition and subtraction come last in the order of operation, because they're weakest. So if I have a negative 3 plus a positive 5, this means I'm going to go negative 3 to the left, and then I'm going to come back positive 5 to the right, which is why the answer is a positive 2. If I have a negative 1 plus a negative 4, so negative 1 will go 1 to the left, a negative 4 will go 4 more to the left, so the arrows are being laid right next to each other, which is why the answer is a negative 5. Multiplication and division, though, are stronger operations. In a sense, they're strong enough to bind the two numbers as one. We can visualize this with a rectangle. So with a rectangle, it's got a length, it's got a width. But when we multiply them together, we find the area of the rectangle. So the length times the width binds those two numbers together as one rectangle. So all by itself, a length of 3 could just be out there somewhere. A length of 2 could just be out there somewhere. But when we put them together like this, we multiply them together, and we get this area, it binds them together as one number, 6 square inches. So with that being said, when we multiply, all the negative signs will actually be part of our answer. They're all tag along. We're going to look briefly at this, but then I'm going to teach you a shortcut for the homework in the future. So don't get too caught up in what we're about to talk about, but this is kind of the basics of what's going on. So first of all, 5 times 4 is 20. We know that. That's nice and easy. Those are the positives. But then when I have a 5 times a negative 4, again, 5 times 4 is 20, but then this negative sign will tag along to my answer. So 5 times a negative 4 is a negative 20. Likewise, a negative 5 times a positive 4, well, 5 times 4 is still 20, but this negative now will tag along to the answer. So it actually doesn't matter which number has the negative on it. If there's just a single negative, your answer will be negative. And then finally down here, a negative 5 times a negative 4, 5 times 4 is 20, but then technically both of these negatives tag along to our answer. Now again, this is the part that I don't want you to get too caught up on, because we're going to learn a shortcut for that right now. And to learn it, we actually have to go to the next page. So, notice that the last example, negative 5 times negative 4, resulted in a double negative. A negative sign really means opposite. So let's look at what results from a double opposite. So if I asked you what's the opposite of tall, hopefully you would say short. So then the double opposite would mean I take the opposite of that again. Well, it would be back to tall. If I ask you what the opposite of cold is, I hope you would say hot. So then the double opposite, so the opposite of that again, would be cold. The opposite of slow is fast. So then if I take the opposite of that again, I'm back to slow. The opposite of young is old. And then the opposite of that again is young. The opposite of 20, positive 20, is a negative 20. And now here's the key. Technically, the double opposite would be the negative 20 that we saw on the front. But look at what happens here. Anytime you take the opposite of something, and then you take the opposite of again, we see that in a double negative, a double opposite, that the two opposites cancel each other out. So really, instead of a negative 20, this really just becomes a positive 20. The two negatives really just end up canceling each other out. So let's flip back to the front page again. And so the shortcut we've discovered here is that we're not going to write that. Because what's going to happen is 5 times 4, sure enough, is going to be 20. But then the two negatives, that pair of negatives, will cancel each other out. and it will just be a normal positive 20. So two negatives will cancel each other out. A double negative will cancel. So in a double negative, the negatives cancel. In a double negative, the negatives cancel. So here's our shortcut. Shortcut for multiplying positive negatives. Well, first of all, positive times positive, that's what we've always known. It's positive. If I have a positive times a negative, well, then that negative sign will tag along to the answer, making the answer negative. Likewise, if I have a negative times a positive, then this negative will tag along to the answer, making it a negative. And then finally, if I have a negative times a negative, well, both negatives will go to the answer and cancel each other out, which means if it's canceled out, the answer is really positive. Or another way of looking at it, if the signs are the same, so if they're both positive or they're both negative, then the product is going to be positive. Oops, forgot my I there. Positive. There we go. So if they're both positive, the answer is positive. If they're both negative, the negatives cancel and it's still positive. However, the signs are different. That means there's going to be an uncanceled negative there, which means the product is negative. So in the end, ladies and gentlemen, if you're not quite following the whole things canceling, the shortcut here of it is, if you can memorize these two statements, you got it. The shortcut for dividing positives and negatives, it's actually the exact same rules as multiplication. So a positive divided by a positive is positive. A positive divided by a negative is negative. A negative divided by a positive is negative. A negative divided by a negative is positive. Or if the signs are the same, the quotient is positive. If the signs are different, the quotient is negative. Same exact rules. So ladies and gentlemen, we're going to flip the page over. We're going to take a look at some examples. But you'll notice that all these examples I focused in on multiplication just because that's often easier to work with. But remember, the rules work exactly the same for division. So if you want to decide if it's a positive or negative, it works exactly the same here. So for my first example, I have a positive 4 times a positive 9. So the way that I'm trying to get you to gear up towards thinking about that, there's no negative to carry on to the answer, which is why a positive 9 times, or positive 4 times positive 9 is the positive 36 that we're used to seeing. Next, 5 times 6 is 30. And the two negatives, the double negative, will cancel, so it is just 30. Ladies and gentlemen, as you start getting more and more comfortable with these, I recommend that you pause the video and then hit play and see how you're doing. I'll leave it up to you how far ahead you want to work before you hit play on the video. So next up, 10 times 12 is easy, that's 120. But then there's a single negative to tag along to the answer. 4 times 3 is 12. Again, there's a single negative to tag along to the answer. 9 times 6 is 54. But there's a single negative to tag along to the answer. 7 times 3 is 21. But there are no negatives to tag along. So that's just a positive 21. Remember that multiplication can be expressed using parentheses, so we've got a few more here. And this can be actually really useful when it comes to negatives. You'll often see, particularly in your book, that the negative sign in your book is often so low that it looks like a minus sign. So by putting parentheses around it, it can make it more obvious that we're not talking about a minus 7, we're talking about a negative 7. So the difference between subtracting 7 and minus 7, they are related, but not exactly the same thing. So a 7 times 4 is a 28, but again I have a single negative to tag along to that answer. 8 times 7 is 56. Double negative, though, will cancel, so it's going to be a positive 56. 2 times 2? 4. That's easy. 11 times 11. This is one you may or may not have memorized. 121. But again, double negatives will cancel. So it'll be a positive 121. 9 times 9 is 81, with a single negative to tag along to the answer. 7 times 7 is 49, with a single negative to tag along to the answer. Next column. 4 times 9 is 36, but this time we have a single negative to tag along. A negative 1 times positive 18. 1 times 18 is 18, but I've got a single negative, so it'll be a negative 18. 6 times 2 is 12, but with double negatives, they're going to cancel, so it'll just be a normal positive 12. Positive 25 times positive 3, that's really just your plain old 25 times 3. So 25 in quarters, so 3 quarters would be 75 cents. And now we're going to take a look at examples where we've got more than just 2 factors, but the same rule is going to apply as before. So I'm going to work this out. I actually, since it's multiplication, I can do it in any order I want. So I'm going to do 2 times 4 first. 2 times 4 is 8, and then times 9 is 72. Now I've got a negative here, and I got a negative there. Well, that's a double negative. So that means all the negatives are going to cancel, and if there are no negatives left, this is just going to be a positive 72. Down here, again, multiply it any order you want. This one's easy enough. Let's just go forward. So 2 times 3 is 6, times 4 is 24. But this time I have just a single negative. Remember, negatives only cancel in pairs. So you need to have a pair of negatives in order to cancel. So without a buddy to cancel them out, that negative will tag along and make my answer a negative 24. All right, a few more examples here. So 30 times 50, remember this is going to be like 3 times 5, but then it's going to have 2 zeros at the end. So 1,500, and since there's a single negative here, it will tag along to the answer. 10 times 40, negative 10 times negative 40. Well, 10 times 40 is 400, but a double negative will cancel, so that'll just be normal positive 400. Positive 6 times positive 7 really is just our normal 6 times 7, so 42. 5 times 8, or 28. I'm going to give you a little shortcut for multiplying by 5s. 5 is half of 10. So if you know that 10 times 28 is 280, well, 5 would be half of that. So half of 280 is 140. And then double negatives will cancel. Now we're back to having 3 numbers. A negative 3 times a negative 8 times a negative 2. So I would do 2 times 3 is 6, times 8 is 48. So that's my number. Now I've got 3 negatives, so technically 3 negatives would carry on to my answer, would tag along to the answer. But anytime you've got a pair of negatives, that pair will cancel. So if I think about it here on my dry erase board, this number is going to have 1, 2, 3 negatives. But 2 of them will cancel. So do we have any negatives left over to tag along to our answer? Well, yeah, we do. So this actually would be a negative 48. So 2 of those negatives will cancel, but because 1 doesn't, it tags along. And then finally, for our last answer, 23 times 19, I don't honestly care what it is. Because when we're done with that, we're going to multiply the whole thing times 0. And what's the rule for multiplying by 0? Doesn't matter what the other stuff is. The answer is always 0. So keep your eyes peeled for those. Sometimes the book will throw those at you. Well, they'll do a bunch of stuff, and sometimes it'll be like 23 times 19, where you probably don't have that memorized, and you probably don't have a nice little trick for doing it. But then it multiplies by 0, so it doesn't matter. It's just 0. And that, ladies and gentlemen, is the end of our lesson.